So sometimes differential equations given to you, and you'll be given initial conditions, and there'll be unknowns in the solutions. So in the process of solving this, usually we given the differential equations, you will try to solve it by integrating both sides, separation and so on, those techniques. You come to this here, and if you have initial conditions, you can then find the value of m or any other constants or coefficients that may arise in the solution. So in this case, because we already given the solution, general one, but not knowing the value of m, so all you need to do is just differentiate this again and substitute this into here, and then we use the initial condition to help us to find the values of m. So first we derive this with respect to x to really double check that this indeed will give us dy dx equivalent to 4x, which is the same as here. So now it's verified that this is indeed a general solution to these differential equations. So then what we need to do then is just to substitute this y4 and equivalent to 10, and we should get what we need. So this means that we're going to substitute x by 4 and then y by 10. And so substituting this x with 4 and then y 10 will end up getting here. So then if you resolve this, your m will be equivalent to the negative of 22. So that will be the value of m. Let's look at another examples with somewhat more complicated and see how it goes. So this example is somewhat complicated because the function itself is not easy. It contains a long log function, ln x, and then this is a power of a power function, part of it. So our task is first to derive this, and we'll see what will happen. I suggest that we do that first and then see how that goes. If we differentiate this now, you will have dy dx that be equivalent to a. We know that deriving ln x would be 1 over x. So that is actually a over x to be fair. And so this is a b, is a coefficient. And the c is actually, power rule says you can write bc x c minus 1. And then the d is a constant, so it's 0. So here I rewrite this, the left hand side or right hand side of the differential equations. So a task we can compare. If we compare this, they have very similar looking terms. So clearly you can see that a is really 3, and then bc, the product, is 3, and then c minus 1 is 2. Now then that means that a will be equivalent to 3, and then c minus 1 is 2, so that means c equals to 3. And finally, because bc is equivalent to the coefficient 3, and that means that b is equal to 1. Now what we're going to do now is that we rewrite the equations, or rather the solutions of here, given here, or this one, with a, b, c replaced by the given the values that we obtained. And so with a, b, c all substituted into all those the coefficients and so on, you get this. But the d is still unknown, but no worry there, because we have initial conditions given. So using this initial condition, we should be able to calculate for the value of d. And so substituting this initial conditions with this here, well, we should be able to show that d is equivalent to 8, I think. So the idea is that even initial conditions and forms of the differential equation you can even differentiate this to get the necessary values for all the constants and coefficients and so on. And here the use of initial condition will be very useful always to determining certain constants, values of constants.